Have you ever stopped to think about how our wireless world actually works? I mean, really think about it. How can millions of us, all in the same city, be on our phones at the exact same time without it all just collapsing into a giant mess of static? It all comes down to solving one massive problem. How do you share something limited, like the airwaves, fairly and efficiently?
Right. Let's zoom in a bit. Picture yourself at a huge concert or a packed stadium. You look up, you see one, maybe two cell towers. How in the world are thousands of phones connecting to that single point all at once, sending texts, making calls, posting videos? It feels like it should be impossible. Kind of like everyone trying to shout at the same time in a super crowded room. Just total chaos.
Well, the solution is kind of beautiful in its simplicity. Instead of that chaotic free-for-all, the whole system is built on a rule we all learned as kids. Everybody gets a turn. It's that simple idea of organized, super-fast turn-taking that is the absolute key to our modern digital world. Now, the technical name for this is TDMA, which stands for Time Division Multiple Access. Okay, let's break down that fancy name. Multiple access. That part's easy. It just means lots of users can get on the network. But the time division part? That's the secret sauce. It tells us how they do it. They literally slice up time itself into tiny little pieces.
So how does this time slicing actually work in the real world? Let's get into the core principle of how TDMA pulls this off.
Okay, so take a look at this. You've got Station 1, Station 2, Station 3, and they're all talking on the exact same frequency. But, and this is the trick, Station 1 transmits only in its tiny slice of time, and then boom, it goes silent. Then it's Station 2's turn. It transmits and it goes silent. Then Station 3, and on it goes, in a crazy fast repeating cycle. And that right there is the whole game. It's the core idea. You see, unlike other methods that might divide the frequency into smaller channels, TDMA gives each user the entire frequency band, but only for a split second. It's not about owning a little piece of the airwaves. It's about borrowing all of it, just for a moment.
Now, you might be thinking, what if one person's time slot kind of bleeds into the next one? Well, to stop that kind of interference, what they call crosstalk, the system is incredibly precise. It puts these tiny empty gaps of silence, called guard times, between each person's slot. You can think of it like a little buffer zone, just to make sure nobody's conversation accidentally bumps into someone else's.
So what this means is your phone isn't actually transmitting constantly when you're on a call. Nope. Instead, it gathers up a little chunk of your voice or your data. It waits for its assigned microsecond, and then it shoots it all out in one super fast, compressed burst. They call this the buffer and burst method, and it's what makes the entire system so incredibly efficient. All right, so we've got the basic principle down. Now let's dig into some of the key features that made TDMA so foundational for building the digital cell networks we rely on today. First off, this whole bursty way of sending data is perfect for digital information, which is already broken up into ones and zeros. Of course, to make this dance work, everything has to be perfectly timed down to the microsecond. That precise synchronization is absolutely non-negotiable. And like we just talked about, those guard times are essential. But here's a huge win. It's really power efficient. Because the phone's transmitter is actually turned off most of the time, it saves a ton of energy. And that power efficiency leads directly to something we all love: better battery life. Since your phone is only transmitting in these quick little bursts, it uses way less power. It also makes the phone's hardware simpler. A phone usually needs these complex filters called duplexers to send and receive signals at the same time. But with TDMA, since you're sending in one time slot and receiving in another, you just don't need them. And finally, this whole structure makes the handoff process, when you're driving and your phone switches from one cell tower to the next, much smoother. So if you had to boil this all down to one single idea, it's this: in the crowded world of wireless signals, timing is everything. It's a powerful lesson that managing time can be just as important, if not more important, than managing space or frequency. And that kind of leaves us with a final thought to chew on. This principle of dividing up time to get things done efficiently, it's everywhere once you start looking for it. It's in the way computer processors handle tasks. It's in how traffic lights manage an intersection. So where else do you see this elegant solution of taking turns, making our complex world actually work? Something to think about.